Hi everyone, welcome to the CodeTab management. So we have discussed about the intermediate operations under the Stream API in the previous lecture. So if you have not visited yet, just go to the Java 8 features playlist, and from that you can find all the features of Java 8 and also the Stream API previous parts. So this is the part 4 for the Stream API. So here we will discuss basically about the terminal operations, right? So first one is count. So the method signature is like that, long count. So when we will use this count? So when you want to determine the number of elements in a finite string, for that you can use this count operation. So let's take an example. So here, this is a stream of strings where some animal names are there: cow, tiger, elephant. So here you will count the number of strings there in this stream. So you got the 3 as the output, as 3 inputs are there. 3 animals are there. That's right. So this is the syntax. Next one is min and max. So for the min and max, remember, you will use this optional. So when you want to find the smallest or largest value in a finite string, for that case, you will use min and max. So as the method signature represents, the min and max methods allow to pass a custom comparator. Here you can see, right? Custom comparator you are passing. And also, if you want to find the smallest or the largest value in a finite string, according to the sorting order, then you can use the min and max. And also, like this count, these are the basically reduction operation, as you will get only single value after doing this operation, or from a stream you will find only single value. So reduction operation you can also say. So like here, one stream of strings is there where the strings are Java, Python, Scala. So here you need to find out which one is the minimum string, minimum length string. So it will calculate according to the strings. It will check the differences between the string 1 length, string 2 length. Then again, it will take S1 as Python and then Scala. So by doing the difference between the length of the strings, it will calculate the minimum. So here you can see that the length of the Java string is 4, the Python is 6, and Scala is 5. So the minimum is Java. That's why Java is printed here, right? So next one is find any and find first. So here also optional. So if you wish to find the first element in a stream that satisfies a particular condition or business logic or business requirement, then you will use the find first. And the find first and find any methods in stream return the optional, okay, describing the first element of a stream. And this find any or find first don't take any argument, okay. So for that, you need to be sure that there some mapping or filtering operations have already been done. And the find any method returns optional, describing some element of the stream, or an empty optional if the stream is empty. And in a you can say as a non-parallel stream, means non-parallel operation, find any will most likely return the first element in the stream, okay. But there is no guarantee for this find any, okay. So if you are not sure about the specific thing, so you can use the find any there. So basically, so I'm giving you one example where, so there is a list of integers to find the first even number. So apply an even number filter. So filter, then you are calculating that the modulus 2 is 0 or not. And then you are calculating the first even number. So here for this stream, the first even number is 8, right? So 8 will be printed here. And then if the stream is empty, the return value is empty, optional, okay. So here you have seen like this is the optional result 8, and here also. So like here this is stream of some integers 9, 5, 8, 7, 4, 9, 2, 11, 10, 3. So then first of all it is filtering the numbers are greater than 10. So from this stream the resultant stream will be only 11, as only 11 is greater than 10. And then again it will do some filtration that the resultant stream from the previous filtration will be divided by 5 or not. So 11 was the output from the previous filtration. 11 is not divisible by 5, right? So that's why you will get empty string. So if you will take the find first there, so you will get the empty result. So output will be optional dot empty. After that, any match, all match, none match. So method signature is like that: boolean, any match, then predicate, then super T predicate. Same for all: boolean, boolean. Okay. So in which case you will use that one? So when you will use to determine if any elements in a string match a predicate, or if all match, or if none match, then you will use the methods any match, all match, and none match according to your requirement. Okay. So here a list of skills, this array list is there. Okay. Then you need to check this any match, all match, or none match. So one predicate where input type is string. Here we have given array list as the array of strings, Core Java, Spring Boot, Hibernate, Angular. Then we are checking that you need to check that string which starts with S later, right? So here you can see only for the Spring Boot it's starting with S. So if you will do by any match, then it will check whole the string. So it will find that Spring Boot is the string which is starting with S. So it will give you the true result. Here I have already told you that all the types are Boolean. So it will give true result. Then all match, all are not starting with S. So this is false. And none match, this is also false, because one already matched that starting with S. So if we will do this none match, then it's also false. Then the for each method signature is like void for each, then consumer action. So when you want to iterate the elements of a string, then note that this is the only terminal operation with return type of void. Okay. So you can call for each directly on a collection or on a string. So Stream API in Java 8 cannot use a traditional for loop to run because they don't implement the iterable interface. This is one of the important question. I'm writing that question here under this when to use for each. Here one sub question may be asked. Okay, like in Java 8, we can't use terminal for loop to run. So what is the reason for that? So reason is they don't implement the iterable interface. Right? So this is one of the important questions. So here, this example will demonstrate that the concept of the Stream API in Java 8. So some stream of skills is there. So when you will use the for each, so it will basically print all the skills one by one, like Java, Python, Angular. Next one is collect. So here also, first of all, see the method signature, the collect, and here the supplier by consumer. Okay, this accumulator, then by consumer means a combiner, means supplier by consumer, accumulator by consumer, combiner. These are there, right? So one important point, please note, like collect method does not belong to the collectors class. It is defined in the stream class, and that's the reason you can call it on stream after doing any filtering or mapping operations. However, it accepts a collector to accumulate elements of stream into a specified collection. So as this is not under the collectors class and it is defined in the stream class, that's why you can call it on the stream after doing any kind of filtering, any kind of mapping operations. Okay. Then when to use the collect. So this is one of the important point. And also I'm going to tell you that the collectors class provides various methods we have, right, in the collectors class. You can say some name like toList, toSet, toMap, toConcurrentMap, to collect the result of the streams. So you do, right, collect.collectors.toList, right? In several examples, you can see .collect, collectors.to collection, or to list. Here you can see to set, to map, this kind of. So why we use this? So we basically use this to collect the result of the streams into list, set, map, concurrent map. Okay. For that reason, we use the toList, toSet, toMap, toConcurrentMap, these kinds of methods. So most of the time when you want to convert a stream to collection, which you got after applying various operations like filter, map, okay, then you will use the collect. So basically it allows you to accumulate the result into a choice of containers you want, like list, set, map, according to your choice. Okay, so like here is one example. Here you can see some stream of skills are there. Then I will check that skills which are starting with S. So it is checking that the string which is starting with the character S. So X dot start with. Then we will collect through this collectors dot to list, collecting the result of a stream into a list. And then through this for each, we are just printing the results. So Scala and Spring, these are starting with S. So we are returning these two. Okay. And here you can also convert according to your choice, like array list, has set, linked list. So here we are using or collecting the result of a stream into a list of our choice. So here we will check or filter from the stream of skills that the strings which length is greater than 3. So first of all, we will do this filtration where we will check the length is greater than 3. Then we will collect the results as the array list. Okay. And then through this for each system out println, we will just print those results. Next one is reduce. So this is the method signatures, you can say. So one can ask you that identity is there. So what is the identity? So basically an element that is the initial value of the reduction operation and the default result if the stream is empty. So that is the identity. Okay. So mainly this is the initial value of the reduction operation. Then what is the accumulator? The accumulator basically, this is a function that takes two parameters. Okay. So a partial result of the reduction operation and the next element of the stream. And these are the two parameters. Next is combiner. So what is the combiner? This is also a function that we use to combine the partial result of the reduction operation and means when this partial result is basically when you will reduce in a parallelized form or when there is some mismatch between the types of the accumulator arguments and the types of the accumulator implementation. So for that case, we use to combine the partial result of the reduction operation. Then we will use this combiner function. Okay. So basically, when you will use this reduce, so when we wish to produce one single result from a sequence of elements by repeatedly applying a combining operations to the elements in the sequence, for that case, we will use the reduce. And here I'm going to discuss two examples. So first one is the array list of letters where some characters are there like C, O, D, E, T, A, B, and this will basically do the reduce to a combined form. So for that, we have used this partial string plus element. So this partial string and element, these two are there, right? So binary operation is there, means binary operator is there. So first one is this binary operator and accumulator. So basically, it will combine this partial string with this element, and it will give us the result. So this COD, TAV, all will be combined and it will form the code tab. So this is the thing, but we can also reduce this via this one, like letters.string.reduce, then the string concat. Okay, in this way we can reduce. Next one is the, so if here I have discussed about the identity and reduce accumulator combiner, right? So in this example, if you want to know about the what is the identity, so this is the identity. Okay, and it indicates the initial value of the reduction operation. I have already told you the initial value of the reduction operation is the identity, and also the default result when the stream of string values is empty. Okay, and here likewise the lambda expression. So partial string comma element, this means this one, it is the accumulator. So as it takes the partial concatenation of the string and the next element in the string. So first one is CO, means CO, then it will make the CO, then CO is the partial string, right? Then the next element is D, then it will make COD, then COD is the partial string, then next element is E, then CODE, then the partial string is CODE, the next element is T, then CODET, then CODET is the partial string and A is the element, and then it will form the CODETA, and then the next element is V, and finally it will make the OTAV, right? And this is the one liner, means through this we can reduce the expression. So the another example is like that. So here, this is one binary operator OP. So A comma B, then A star B, stream empty, then stream one element, stream of 3, then stream 3 elements, stream of 3, 4, 5, then empty dot reduce OP. If present, then system out dot print. So nothing is there. So no output is there. Then one element means this one element dot reduce if present. So present 3 is there, right? So 3 is printing. And then 3 elements. So present, then it will do what? Operation OP will be calculated. That's why 3 into 4 equals to 12, then 12 into 5 equals to 60. So 60 will be the output. So in this way, basically, the terminal operations works. So hope you are okay with that. So if you have more questions, again, we will discuss. Okay. So that's all for now. Again, we will meet in the next lecture. Till then, just do like, share, subscribe, and obviously learn more and more.